Hi all, I'm Saujanya Karri, currently working as Principal Technical Engineer in Oracle. And today I want to talk about the topic Explainable Generative AI Models for Anomaly Detection in Transactional Finance Data. So, detection in financial transactions is the critical component in combating fraud and ensuring regulatory compliance and also safeguarding the user trust. With the exponential growth of the digital transactions in the financial sector, the threat has significantly expanded and also making anomaly detection a very critical component. So, these anomaly transactions often indicative of fraud or money laundering or system errors, which we require timely and accurate detection mechanisms to evolve the patterns and behaviors. The traditional rule-based systems and also even some machine learning models fall short in detecting these anomalies in high-dimensional financial data. And in recent years, deep generative models such as variational and autoencoders and generative adversarial networks have shown very promising in modeling the normalization and distribution of transactional data and also identifying the outliers based on the latent space deviation. However, despite their accuracy, the lack of transparency and interpretability in those models in regulated financial environments where decisions must be auditable and explainable. So, this topic mainly aims to provide the research which will bridge the gap by integrating explainable artificial intelligence, which is often called XAI methodologies, into generative AI models, which enables not only robust anomaly detection but also transparency and trust in financial decision systems. So, with the quick digitization of financial services has greatly increased, it has also led to an increase in unusual and fraudulent activity. So, finding these anomalies, which points to fraud, money laundering, has become crucial because we have millions of transactions every day that takes place in real time. And these generative AI models, such as variational auto encoders, have gained popularity for their ability to learn complex distributions and identify irregular transactions without needing explicit anomaly labels. Despite their effectiveness, these models often criticized because it making it difficult to understand or justify the decisions how they make and where the transparency is essential for the regulatory compliance. And in order to get around this, we are combining by looking into these generating models with explainable AI, which is XAI. So this combination creates new opportunities for creating reliable, interpretable, and also accurate fraud detection systems. Um, while deep generative models like variational autoencoders have demonstrated strong performance in detecting these anomalies, their inherent black box nature presents a serious challenge in real world deployment. And like financial institutions which operates in heavily regulated environments, they are requesting for automated decisions, and those must be transparent and auditable. And current generative models often lack those mechanisms for explaining why a particular transaction was flagged as anomalous or limiting user trust and regulatory acceptance. So, this is a very critical need for a unified approach that combines the anomaly detection capabilities with inbuilt interpretability features, enabling both high detection accuracy and transparent decision making. The primary objective of this topic is to develop an explainable generative AI framework for detecting anomalies in financial transaction data. Specifically, the model aims to integrate the variational autoencoders with attention mechanisms and SHAP based explanation layers to achieve both high anomaly detection accuracy and also interpretability. Also, evaluating the model on real world financial data set provides the performance, and also we can compare with existing methods, which will provide the results for interpretability, aware loss, that improves explanation fidelity without compromising the detection quality. This topic in this paper we mainly presents some key contributions to the field of financial anomaly detection. So we proposed a explainable VAE framework that integrates attention mechanisms with the decoder and incorporate SHAP values to enhance interpretability of anomaly detection. And we conducted extensive evaluations on IEEE CIS fraud detection data set. Actually, that is a data set which has very good financial data to test for these anomaly detection and all. And by using different evaluations, we demonstrated competitive performance compared to baseline models such as isolation forest, standard VAE, and anomaly. And we also provide we can provide visual and attribution based explanations for autonomous transaction detection, supporting compliance requirements and analysts understanding. And for financial decision systems to be transparent and trustworthy, explainable artificial intelligence is very essential. In order to help analysts comprehend model predictions, methods such as SHAP offer feature attribution based on the Shapley values. And there are some gaps in existing research. Although generative models have demonstrated robust performance in fraud detection, their lack of built-in interpretability limits practical adoption in financial institutions. And most existing solutions apply this XAI post hoc, which can lead to explanations that are misaligned with model reasoning. And furthermore, few studies have explored integrating interpretability directly into the training process of generative models. This creates a clear research gap in developing end-to-end explainable generative frameworks that balance detection accuracy and transparency. So this is the proposed framework. We use the IEEE CIS fraud detection data set for this work, which was made publicly accessible also, and with more than 590 rows and 434 characteristics. The data set is of anonymized e-commerce transactions, which we can use to replicate the actual fraud detection scenarios in online payment systems. So the dataset is mainly divided into two primary files. One is train transaction data and one is train identity data. So the train transaction data contains transactional features such as transaction amount, product type, card details, and email domain information, etc. And train identity usually includes transactional features such as device type, browser, screen resolution, and operating system. So the model performance and generalizability depend on high quality data pre-processing, particularly in delicate areas like fraud detection. And despite have many features, the IEEE CIS dataset has a large number of missing values, anonymized fields, and inconsistent entries that may interfere with learning. So to deal with this missing data, We can align identity and transaction files and remove noise without affecting the essential transactional patterns. Data cleaning procedures were also carried out. And this proposed framework integrates variational autoencoders with an attention mechanism and SHAP-based explanation to enable both anomaly detection and interpretability. And as shown in this picture, the pre-processed transaction data is passed through an encoder to generate the latent representation, which is then refined using an attention layer to highlight important patterns. This enriched latent code is used for the decoder to reconstruct the original input, and anomalies are identified based on the reconstruction errors. And the encoder, the latent space, and the decoder with an attention mechanism are the three main parts of this suggested design, which is based on a modified variational autoencoder. The high dimensional input transaction data is converted into compressed latent space representation by the encoder network, which is then connected with the neural layer. And in addition to acting as an information bottleneck, the latent space is essential for identifying underlying transaction patterns. And using the latent representation, the decoder network recreates the initial output. The decoder incorporates the attention mechanism to enhance the interpretability and also focus. And this technique effectively highlights which features contribute more to each reconstruction by learning to give dynamic weights to various latent dimensions. So, by highlighting the most significant latent features, this selective emphasis improves interpretability in addition to the anomaly detection accuracy. So these are the results. So the experimental design, baseline comparisons, and performance assessment of the suggested explainable VAE framework are presented in this section. If we can see, uh, and also the purpose of these trails were to confirm the model could reliably identify unusual transactions and also provides clear, understandable results. So both quantitative and qualitative indicators were utilized to evaluate the explainability and detection accuracy. And these findings demonstrates the benefits of combining SHAP-based attribution and attention in a generative model for detecting the financial anomalies. So to validate the performance of this framework, I compared it with against three widely used baseline in unsupervised anomaly detection. So the isolation forest, standard VAE, and anomaly. So the isolation forest is a tree-based assemble model that isolates anomalies through recursive partitioning. Standard VAE is without attention or any SHAP. So this is vanilla VAE to test the impact of the interpretability layers. And anomaly is a GN-based anomaly detection method which used the encoder decoder encoder structure. So these baselines were selected due to their popularity and also success in fraud detection settings. And if we see here, the performance of all models was assessed using the standard classification metrics derived from the confusion matrix, precision, recall, and F1 score and AUC. So precision is the proportion of predicted frauds that were actual frauds. Recall means the proportion of actual frauds that were successfully detected. F1 score is harmonic mean of precision and recall. And AUC is area under ROC curve, which measures overall discriminative ability. And here, as shown in this table, the proposed model outperformed all baselines across precision, recall, F1 score, and AUC metrics. The proposed model achieved strong performance across multiple metrics, outperforming baseline models on both detection and interpretability. And as shown in this picture, the precision is 0.81, recall is 0.72, F1 score is 0.76, and AUC score is 0.91. So this demonstrates the model's ability to effectively detect fraudulent transactions while maintaining a low false positive rate. So the suggested explainable VAE effectively strikes the balance between interpretability and detection performance. In contrast to conventional black box models, it maintains a good AUC and F1 score while providing transactional level explanations using SHAP integration. Our model shows a better trade off between transparency and sensitivity than baselines such as regular VAEs or isolation forest. However, a few limitations still exist. SHAP computation is resource intensive, and model performance may degrade in real time streaming due to retraining needs. But still, the framework lays very strong foundation for future enhancements such as hybrid models with transformers or multimodal learning, which involves the transaction text and metadata. So, in order to detect the anomalies in financial transactions, this study suggested an explainable generative AI framework based on a variational autoencoder coupled with attention mechanisms and sharp explanations. And the model also met the requirements for accuracy and interpretability in regulated environments by successfully identifying the fraudulent activity and providing the feature level transparency using the sharp values. So, through integrated explanation layers, the suggested approach demonstrated enhanced anomaly identification while preserving interpretability when compared to the baseline models. And for further improving the performance and scalability in financial systems may involve investigating transformer based or hybrid designs and integrating multimodal data sources. Okay. Sure thing. Okay. Uh, Okay, what motivated you to get into this field? Actually, I have been working in finance from start of my career. Till now, I used to work on different financial modules like account receivables, account payables, and worked in cloud infrastructure applications. But once the AI came into the picture, I want to learn more about how AI helps in finance, because right now, for any period close process or any month end close process, it is taking more time when compared with AI in cloud applications and all. It is taking around minimum of 4 days. So I hope, and also and also I just want to learn what are the I always try to learn new technologies, so that's why. Yeah, thank. Should AI prioritize accuracy or fairness? Mm, I mean, it depends upon what model we use to integrate to our financial data. So I believe, like, I always look for the accuracy models. Yeah. Do you think people overestimate or underestimate AI capabilities? Mm, Actually, AI, as per my knowledge, AI is very useful, but it depends upon the it depends upon us how we need to use that. We can either use that to improve, and also we can also create new products which will be useful for the world. So I believe it has some capabilities, but we should use it in a right way. What worries you most about how AI is currently being used? Like, there are so many benefits if we want to. As a experienced person, I understood that if we want to use these AI capabilities in our regular work, and so that it will be helpful to become a leader, and also it can improve our leadership opportunities also, because you are all know that right now the AI is very leading in our market, and we should learn all the new concepts, because if we see the like Amazon cursor right now, all the developers were using that, and it is taking very less time to complete the development work and all, right? So so we have so many capabilities using AI, and we should use it in a right way. Yeah. Yeah, I think thank you. Thank you. Thanks a lot for giving me this opportunity. Thank you all. Bye.